Hey guys, welcome back to part C of 2023 Canadian Math Kangaroo for grade 1 and 2. Get your thinking caps on and let's have some fun. Ready? Let's go. Problem 13. The map shows 5 villages A, B, C, D, and E, along with the distances between them. There are 2 villages which are the same distance from each other, no matter which direction you take. What are the 2 villages? So we have to find the distance between 2 villages and they should be the same distance. This is our route and these are our villages. So how can we find this? We will use our options. So option A, B and E. So let's see what's the distance between B and E. So we have 7 plus 5, that is 12. And B to E, that is 2, 6, 8. 8 plus 4, 12. That could be our answer because the distance is same. Let's try other. B and D. 7 plus 5, 12. 12 plus 4, 16. 6 plus 2, 8. This is not our answer. C and E. So C is here and E is here. 10. And from C to E, this direction, we have 2, 7, 8, 9. 9 plus 5, 14. That is not our answer. A and C. So A is here and C is here. So we have 7 plus 2, 9. And 5 plus 4, 9 plus 6. That is exceeding. So no. A and D. So A is here and D is here. So we have 5, 9. 5 plus 4, 9. And from here, this direction, we have 7 plus 2, 9 plus 6. This is exceeding as well. So our option is A, B, and E distance. Problem 14. Sam walks through a 2-story maze from the entrance to the exit, both located at floor 1, the red arrows. In what order will she find the wall stickers? These are our options. So we have 2 floors, 1 and 2. Sam walks through these doors, maybe go through the stairs, go to the second level. We have to find it out what wall stickers he will be able to see. Let's move. So Sam moves from here, sees door, goes in here, goes in here, door, door. He comes in here and then he walks on the stairs and he comes out here. He goes in here, goes through this door, and the first wall sticker he sees is a fish. So let's see which one are the fishes one. This one and this one. The rest we remove. So now we have to see which option is our answer. So we are here, we see a door, we go in here, we see a rhinoceros. So this could be our answer. Option B. Let's move ahead. We move on this door, and then we see the stairs. We come down through the stairs, we see this door, and we see this sticker. That is the one. And then we come here and exit. So our answer is option B. These 3 stickers Sam will see. Problem 15. A lighting engineer in a theater on colored lights according to this plan. So this is his plan. For the first minute, only the blue light was on. For the last 2 minutes, only then green and blue lights were on. For how many minutes were all 3 lights on together? So for first minute, we have only the blue light was on. The last 2 minutes, only then green and blue lights were on. So this area represents a minute. That is what we know from the question. Now we have to find how many minutes were all the 3 lights on together. So we see where all 3 lines are together. So this is the one. So this is 1. And then we see 1 more. And then we see 1 more. So total 1, 2, 3. So our answer is option C. 3 minutes, where all three lights were on together. If you find these videos are helpful and you would like me to create more videos, please subscribe to my channel. Your support encourages me to create more solution videos for you. Now, let's dive into problem 16. Emma finished third in a dance competition. There were 3 dancers between her and last. In total, how many dancers took part in the competition? These are our options. So the question says Emma finished third. So there are 1, 2, 3. So Emma finished third here. There were 3 dancers between her and the last. So there were 3 in between. So 4, 5, 6 and the last one. So that is the last answer. In total, how many dancers took part in the competition? So we have 1, 2, 3, 4, 5, 6 and 7. So our answer is option D. 7 dancers took part in the competition. Problem 17. Malik places one of the 5 pieces on the grid. He cannot rotate or flip the pieces. Which piece should Malik use to cover the numbers with the maximum possible sum? So we have to put this piece on this and see which covers the maximum possible sum. So how can we solve this problem? We will go through each option, sum them all and see which has the maximum sum. So let's keep this option. So we keep it here 7, 6, 3, 8, 2. So we have 2 plus 8, 10, 10 plus 3, 13, 13 plus 6, 19, 19 plus 7, 26. So this option A, sum is 26. Let's clear the screen now. We have option B. So we have 2 cover here, this one, this covers and this. So we have 7 plus 6, 13, 13 plus 5, 18, 18 plus 8, 26, 26 plus 2, 28. So we got 28 for option B. Let's clear the screen. Option C, we could cover 4, 5, 8, 9, 5, 6. And we sum them 4 plus 5, 9, 9 plus 8, 17, 17 plus 6, 23, 23 plus 9, 32. So we got 32 for option C. Clear the screen. We have 1, 4, 5, 8 and 3. So 1 plus 4, 5, 5 plus 5, 10, 10 plus 8, 18, 18 plus 3, 21. Option D, 21. We have 7, 4, 5, 8 and then we have 9. So we sum 8 plus 5, 13, 13 plus 9, 22, 22 plus 4, 26, 26 plus 7, 33. So this is 33. So maximum we got here is option E, 33. This is our answer. Problem 18. Digits 1, 1, 2 and 3 are printed on 4 different cards. These cards are laid out to make an addition as shown. How many different results can be obtained? So these are the numbers laid down and we have made 2 digit plus a single digit. Gives us some number. So how many different results can be obtained by taking 2 digit and adding it to single digit? And these are our options. This problem is a little tricky. I'm going to dive you step by step. I know you can do it. You have reached to the last problem of this series. You guys have done an awesome job and you have no problem in solving this one. So first we will create a 2-digit number and then we'll add it to 1-digit number which does not belong to this 2-digit number. So let's see what I mean. We will create first digit 1, 1, 11 using 1 and 1. We will create 1 and 2, 12, 1 and 3, 13. We'll create now 2 and 1, 21. We will create 2 and 3, 24. And we will also create 3 and 1. So these are the possible combinations of two-digit number. Next step, we will choose one-digit number and add it to our two-digit number. So for 11, we could use 2 and makes it 13. We will use 3, 11 plus 3, 14. And that's it. Now we will move on to our 12 combination. So we will use 12. So 12 plus 1, 13, and 12 plus 3, 15. So for 13, we have 1 and 3 already in the digit, so we will use 2. So 1 plus 1, we already have 1. So 13 plus 1 gives us 14. 13 plus 2 gives us 15. For 21, we will use 1. We have two ones, so we use 21 plus 1, 22. And we will use 21 plus 3, 24. For 23, we will have one combination 23 plus 1 because we have already used 2 and 3 in here. So we have 24. For last two-digit number, we will use 31 plus 1 because we have two ones, 3, and 31 plus 2 gives us 33. So these are our possible sum. Now the different sums obtained are, we have 13, so we cancel other 13 from here. We have 14, we cancel other 14. We have 15 combination, we cancel other 15. We have 22, 24, and we cancel other 24. We have 32 and 33. So let's see how many combinations we have obtained. 1, 2, 3, 4, 5, 6, and 7. So our answer is option B, 7. We have finished part C of the 2023 Math Kangaroo Challenge for grade 1 and 2 together. You have done an amazing job solving these tricky problems. Don't forget to hit that like button and subscribe for more math challenges. And make sure to check out next exciting puzzle. Keep up the great work and see you in the next video. Bye.